Hello, I'm Milad Salek, a chemistry student, and today we're going to explore the fascinating world of nanomaterials. By now, you've definitely learned what are nanomaterials, how many types of them we have, and today we're going to explore together the different ways to synthesize them. So, if we're going to talk about synthesizing nanomaterials, we can divide the very different ways of synthesizing to two major ways: bottom-up and top-down methods. So, what are the top-down and bottom-up methods? Actually, these are not a specific method for synthesizing, creating the nanomaterials. So, they are just two different approaches. Imagine you want to create a nanoparticle with its radius equal to 5 nanometers. How would you do that? Actually, this is the question we want to ask ourselves, and this is why our approaches for synthesizing nanomaterials are divided into two major ways: top-down and bottom-up approaches. In top-down approach, you imagine having a big rock in front of you. You want to create a small piece of stone. How you would do it? You definitely start by breaking this rock into smaller and smaller pieces. And this is exactly what happens in here. If you want to synthesize a nanoscale particle, you can start by grabbing a bulk material which is available around of you. You can use it, take it, and imagine you have a special knife capable of cutting through things to very small dimensions. You'll crop the bulk material into smaller pieces until you reach the desired nanomaterial. So, what about the bottom-up approach? I think you can guess it by now. In this approach, we will stack up the building blocks of the universe, the atoms and molecules, on top of each other to make our desired nanomaterial. If we want to talk about these two approaches in our common language, I would say if the top-down methods are similar to a person breaking a stone into smaller pieces, the bottom-up method is similar to a kid stacking up their toys to build a tower. Okay, now let's explore these two approaches and the different methods we use to synthesize materials. We'll explore the top-down methods together. The first method that we're exploring is the milling process. In this method, we have our bulk material, our reactant, the first material that we use for synthesizing, as a large powder. When I say large powder, I don't mean that our powder size should be actually big, but I mean that it's definitely not in nanoscale. This is one of the most industrial ways to synthesize nanomaterials, by the way. We have this large powder of our material. We put it into the milling machine, and the milling machine has some super tough ball-shaped objects in it, which would grind and crash and smash our powder into smaller and smaller pieces. Imagine grinding coffee beans into coffee powder. When you're making a delicious espresso, what you do is you put the coffee beans into the machine, and the machine grinds it and smashes the coffee beans into smaller particles. That's the same thing that goes on in the milling process. But in here, we have the materials, which are usually metals or ceramics instead of coffee beans, and it's not an espresso machine. It's actually a milling machine. And we have the milling balls as the objects who would smash our particles into smaller ones. The second method that we're going to discuss today is electrospinning. Electrospinning is somehow similar to spraying a liquid. In this method, we have a container of our raw material containing polymer solutions. And we have this kind of surface that we want our nanofibers to be built on. This surface acts as a collector, and we have our container which contains our raw material. Then we apply some high voltage. So now we apply this high voltage, and this high charge separation leads to our polymer to fly through our collector. And when it's flying, it gets thinner and thinner and thinner. I told you, it's the same as spraying a liquid, but here our liquid is actually our polymer solution. So the electric field pulls the polymer solution into ultra thin fibers collected on our collector plate. And that's how we would achieve synthesizing nanofibers. These nanofibers are used in various applications, including tissue engineering, wound dressing, and filters. So the third method that we're discussing today is called wire explosion. In this method, we have a container containing water, or it can be a different solution, it doesn't matter, it just should be conductive. And we have this kind of circuit inside it, an electrical circuit. And as you can guess by its name, in the wire explosion method, we want to explode the wire. So we would achieve metallic nanoparticles dispersed in its solvent. So how would we do that? As I said, we would just make a circuit, an electric circuit, inside our solvent. And we will just apply a high intensity electric current so that our wire would heat up intensively and it will get extremely hot and explode. And whenever it explodes, our nanoparticles, our metallic nanoparticles, would be dispersed in our solution. And we will have a solution of nanoparticles, which we can use it later on to make solid nanoparticles. Imagine a firework exploding in the sky. Wire explosion method is the same similar method. But instead of fireworks, we have this metal wire exploding. Using this method, we can synthesize various types of metallic nanoparticles. And these nanoparticles are used in various applications, including medical, sensors, and more other things. Alright, so let's go on for the last method to synthesize nanomaterials in the top-down approach. This method is called electron beam lithography. When you hear lithography, you definitely hear the word light and graphing. So what does it mean? Historically, it means etching, or let's say drawing, some nanostructure particles, some nanostructure materials on a surface using some source of light or energy. But nowadays, a specific method of lithography is used, named electron beam lithography. As its name suggests, in this method, electron beams are used instead of light. And this is actually a newer technique. So here, as I said before, imagine you're just writing down a nanostructure material on a paper. We have a surface, and we want to create our nanostructures on this surface. This surface has a layer named resist. We have this kind of surface. On this surface, we have a layer called resist. And with our electron beam, which we are actually firing through it, this electron beam would draw our desired nanomaterial on it. And after drawing our desired nanomaterial, we will just etch away this resist layer. And by etching away it, we are actually leaving behind our nanostructure, our pure nanostructure. In electron beam lithography, we have this sort of layer that we want our material to be made of. And we are firing electron beams on it. As you can see here, it's colored in yellow. And we can make literally any pattern that we intend. For example, here, we are actually making an N-shaped character on our layer. So with this way, we can almost make anything we intend to. Think of it like a super precise pen that you have in real world to draw any nanomaterial you want. This is actually an excellent way to create electric circuits, and this is how the chips are made, which are used in computers and mobile phones. Far by now, we've studied different synthesized methods that we call top-down. But you may ask, when do we actually use top-down methods instead of bottom-up ones? Well, the real answer here is it depends. There's not a constant answer. In some cases, you just want a powerful method to be industrialized and to make nanoparticles, nanomaterials in some great scale. For those purposes, this sort of methods are actually better. And by the way, some materials are actually harder to break instead of stacking their atoms or molecules on top of each other. For these sort of materials, our definite choice is top-down methods. To summarize, in this session we learned top-down methods. These methods include the methods we break down the bulk materials into smaller and smaller pieces of materials to reach our desired scale. And we studied 4 methods today, including milling process, which we grind and smash the bulk materials into smaller particles physically. We studied wire explosion, which is simply exploding a wire to reach our metallic nanoparticles that we desire. Electron beam lithography, which is simply using a very sensitive pen to create a very small particle. And at last, we studied electrospinning, which we can create ultra-thin fibers with it. So, in the next session, we're going to study bottom-up methods, which include stacking up atoms and molecules on top of each other to create our desired nano-scale product. Stay curious. I'll see you in the next session.